Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about Chebyshev Low Pass Filter problems. Look at this given problem is obtain an analog Chebyshev filter for the transfer function satisfying the constraint 1 by root 2 less than equal to h of e power j omega less than equal to 1 for the range of frequency 0 less than equal to omega and less than equal to 2. And then another condition is modulus of h of j omega is less than equal to 0.1 for the range of frequency omega greater than equal to 4. So first step, find the given data, we can find an epsilon and lambdas. So we know that thing is this is 1 by root 2, this is 1 divided by root of 1 plus epsilon square, and this is 0.1, so this is 1 divided by root of lambda square. So substituting these two, look at this, 1 divided by root of 1 plus epsilon square equal to 1 by root 2, and then 1 divided by root of 1 plus lambda square equal to 0.1. So by using this I can find a lambda and epsilon. How we means? So look at this, first I need to take a square on both sides. So if you square on both sides, it becomes 1 divided by root of 1 plus epsilon square equal to 1 divided by 2. Now cross multiply it, so 2 becomes this side, so 2 equal to 1 plus epsilon square. This one also we can make it, so make it epsilon alone one side, so rewrite the expression. After that we have a epsilon square, take a square root on both sides, it becomes epsilon. So by solving this we can get an epsilon. Similar method, if you solving this expression we get a lambda. So epsilon equal to 1 and lambda equal to 9.95, we are getting this. So we already know this omega p equal to 2 from this given specification, and then omega is equal to 4. So this is we have 4 values. By using this we can find an n value. So n greater than equal to cos h inverse of lambda by epsilon divided by cos h inverse of omega s by omega p. Just substitute these 4 values, I can get as n equal to 2.269. So next step is to find an n rounding the value. So rounding n to next higher integer, so 2.269. So if you round it to next higher integer, it becomes n equal to 3. So in this case n is odd. So n may be odd or even, depends on that the oscillation curves will be starts at 1.0 or it starts from 1 by root of 1 plus epsilon square. Look at this, I have given a graph for this. So here look at this, so here it starts from here if it is an even cases. If it is an odd, it starts from here these values. So look at this, it may start from here. Always we have an oscillations in the pass band. It may start from 1.0 or it may start from 0.70. So depends on n is odd or even. Next step, we need to find a major and minor axis. So we know that A and B. So for that we need to have an mu. So by using mu only we can find an A and B. So finding a mu we need to have an epsilon value. So we have already find an epsilon value. By substituting we can find a mu value. So mu equal to epsilon inverse plus root of 1 plus epsilon power minus 2. So we have the epsilon value, substituting we get a mu value here. So by using this we can find an A value. We have a omega p, and then we have find a mu also. So by just simply substituting this, so mu equal to 2.414 and 1 divided by 1 by 3, and then mu power minus 1 by 3 and whole divided by 2. So this is the A, and similarly you can find a B value also. So A equal to 0.596 and B equal to 2.087. So we have find out these two values. By using this we can proceed. So next step is to find then poles. So for that we need to have angles. So n equal to 3. So case from 0 to 3, that is 1, 2, 3. So we get a 3 poles. So S1, S2, S3. So for that we need to find a pi angles, pi 1, pi 2, pi 3. So we have the formula pi by 2 plus 2k minus 1 divided by 2n into pi. So we need to substitute k is equal to 1, 2, 3. So if you substitute k is equal to 1, we get a 120 degree. If you substitute k is equal to 2, we get a pi 2 is 120 degree. If you substitute k is equal to 3, we get a 240 degree. So this is pi 1, pi 2, pi 3. So from this we can write a poles S1, S2, S3. So S1 equal to a cos pi 1 plus jb sin pi 1. So this is equal to, we have find a value, substitute this, and cos of pi 1 value plus jb value already find it using this sin pi 1 value. So this is the value for that S1. Similarly substitute this S2. So if you substitute S2, instead of pi 1 we need to find a substitute pi 2. So 0.596 cos of 180 plus j 0.2086 into sin of 180. So sin value will be 0. So only we get a real part. And then S3, so use the same thing. Instead of pi 1, we need to substitute here pi 3. So A cos pi 3 plus JB sin pi 3, that is equal to 0.596 cos 240 plus J 0.2087 into sin 240. So this is get a 0.298 into J 1.087. So look at this, S1 and S3 will be complex conjugate matter, and S2 we have only a real part. So the denominator function is, so we can directly write this value. So S plus real part. So this is S plus 0.596. We can write it as this is a one pole. And another poles we have two things. So we need to write it S plus real part square plus imaginary part square. So this is the formula how we are getting this. So this is the one pole and this is another pole. By combining these two poles only we get this expression. So simply we can write it as S plus real part square plus imaginary part square. So by simplifying this, we get an S plus real part. This is a 0.596. This is for an S2 pole. And for S1, S3 poles, we get S square plus 0.596S plus 3.4153. So by combining these two, this multiply with this. So this is the denominator function. We need to find a numerator function next step. So numerator function, we need to substitute S equal to 0 and then we take the values. So just substitute the S equal to 0. Look at this. So once if you substitute this, so only this value we get it. This also becomes 0 and this also becomes 0. So only we have this value 0.596 into 3.354. If you multiply these two values, we get a 2. That's why h of numerator is 2. Now we can write the transfer function h of s equal to 2 divided by the denominator function. So this is the get it from an s equal to, that is S2 poles, and this is for S1 and S3 poles. So 2 divided by the total transfer function. Thank you.